getting started with Java, I'm going to be using this online compiler called OnlineGDB.com. And after you go there, well, make sure drop this down and select Java. And it gives you a little Hello World program. Now you can use it without signing up, but you can sign up for free. And if you do, it gives you some cloud storage space to store your files. Otherwise, to save your file, you'll need to come up here and download the file right here. Okay, so getting started with Java, and I'm going to be comparing this to C++. Because much of the syntax comes from C++. Starting with the comments up here. This is a block comment, starts with a /* and ends with an */. I'm just going to select it and get rid of it, and then I'm going to replace it. We also have line comments. So if you start with 2 /, like for my students, I would like at the minimum put your name at the top and then maybe homework number, whatever, homework number. Okay, so now another thing about Java that's important is that the file name needs to match the public class name right here, and it is case sensitive. Okay, so this will run right here, so I'm going to hit run, and you can see it prints out the hello world right here. Okay, but if I were to even name this with a lowercase m right here, you're going to see an error because it needs to, again, this file name needs to match that right there. So, you can change this. Maybe you want to name this homework 1. And then in that case, you can come up here, click on the ellipses and rename the file to homework1.java. And of course, it needs to have the .java file extension. Now it should be running again. And remember, hopefully I have another video that kind of explains how Java works. This is running online in I think a Linux computer, but when you compile it, it compiles it to bytecode.class file. I think if you actually sign up, you can it shows you your directory in your files, and I think you'll see the .class files there. And so then the Java virtual machine translates the .class file and executes it. Okay, so now let's talk about this. I'm going to start with, usually for new students, I usually recommend putting the opening and closing brace right under each, on the same level as each other, just because of confusion. But, if you know what you're doing with braces, you can keep the opening brace up there to save a line of code. But this does make it look more organized, I think. Okay, so now the program needs to be within a class. And so we have a public class, and so that is like your container for your program. And so now C++, the entry point to a C++ program is a function named main. And this is what this is right here. But in Java, they call them methods instead of functions. Okay, so the method named main is going to be the entry point to the program. And this, since it's a method like a function, you put a return type. In this case, we put void. It doesn't return anything. That's why we don't have a return statement here. And public means that we can access it from the outside. Static, I like to explain later when I go into object-oriented programming. Static basically means we're not creating objects from it. Okay, and now this is something it would be neat to demo sometime, but for right now, this allows you, if you're running the program from a command line or terminal on Mac, this allows you to send parameters arguments into the program. So I won't really be using it in this class, but it is something interesting to play around with. Okay, and so then this main function or method will have an opening and closing brace, just like that is the container. And remember to always indent. Whenever there's an opening and closing brace, everything is indented. Another opening and closing brace, everything's going to be indented. So you press the tab key to indent. And so now in C++, you could do a cout. Unfortunately, in Java, you're going to have to type all this, system.out.println. Now, the ln means it's going to skip a line. It will do a new line after it prints this right here. You can remove the ln if you don't want to do a new line. So that will not do the new line after it prints that. Okay, and then this is a function or method, and so we have the opening, closing parentheses. And then what we print out, if you're going to print out text, it needs to be within quotations. So that's what that is. So, and then, of course, we can use the \ns work for a new line. I'll run that. There we go. So you can see it does hello \n new line world. Also, just like in C++, there's special characters. For example, if you want to print a backslash, you need to do 2 backslashes because that's a special character. So 2 backslashes will print 1 backslash. Also, if you actually want to print a quotation, you need to do a \, quotation. Same as in C++. Like if I wanted to put a word world in quotations, I'd need to do a \, quote, and then a \, quote right there. And now world is in quotations. Okay. Let's introduce variables. Variables are very similar. They've added a couple more variables than C++, but we still have our integer variable. Let's just say integer age is equal to 20. So let's just say my age is equal to, and now if I want to print that variable, in C++ you'd extend the cout with 2 less than signs. Here, you can extend this with a plus sign. That means append onto this quotation the variable age like that. Okay, so my age is 20, I wish. Okay, so now let's go to, now let's say that we wanted to do a mathematical expression in here. Let's say I wanted to go to, I want to add 20, or let's say I want to add age, but I'm going to add 20 to it. Okay, so now that's not going to work right. Look what it does. It says my age is equal to 20. It prints that plus 20. So it didn't evaluate age plus 20. I wanted it to print 40. Okay, so if you want to have it evaluate, you just put an extra set of parentheses in there. And now this plus sign means addition rather than append onto the output. So we run it, and so now it evaluates it, age plus 20. Okay, so now in my chapters, I have chapter 3. Here's all the different variable types that we have. Many of them are very similar to what you'll see in C++. And declaring variables, you have to do, just like in C++, you have to declare a variable before you can use it. And then mathematical operations. So also, just like in C++, let's just say, if I say output 3 divided by 2, whenever you divide an integer by another integer, let me just remove that, it gives your answer as an integer. So see, this is just going to give you the number 1. An integer divided by an integer gives you an integer. So if you put a decimal point in there, either the numerator or the denominator, I prefer to do both, it will give your answer as a floating point with a decimal point in there. Same way if you're doing up here, int age is equal to 20, let's go 50 divided by 8. And then if I print age here, it's cutting out the decimal point. Yeah, we might add one of those there. Semicolon. Just like C++, lines need to end in the semicolon. So, but if I add my decimal point in there, then... Oh, actually, no, we're assigning age as an integer, so no way I could actually store it as a decimal point. But if I change that to a float variable type, notice it's still going to make it... Oh, okay, it did add my decimal point. Okay, I was thinking it would still divide this integer. Oh, wait, but 6 point... Okay, never mind. We still have an integer divided by an integer, so it got rid of the decimal point right here, stored it into age, but when it prints it out, it's printing the decimal point there. But that answer is not correct. But if we put our decimal point back in here and run it, then it should give us the actual correct answer, but lossy conversion. Okay, I'm actually glad these errors are coming up. So what it's saying is that we could be losing some information right here, converting from double to float. That's why I usually like to use the double variable type so you don't get that warning, that error right there that we just saw. Okay, so I usually use double instead of the float. Back in C++, we can do, let's just go int age is equal to 40. Just like in C++, we can go age plus plus, which means increment age. Age minus 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 means decrement age, subtract 1. So now age is back to 40. Okay, we can also go age, reassign a value, age plus equals 5. That means the same as age is equal to age plus 5. Same thing as in C++. This is the shortcut way of writing that right there. So now age should be equal to 45. We increment, decrement, then add 5 to it. Okay, so you can use either format right there. And then, of course, modulus, the modulus operator, that gives us the remainder in a division. Okay, so let's just say age is 45. Age is equal to age mod 8. Okay, so how many times will 8 go into 45? Well, you've got 8 times 5 gives you 40, and so the remainder would be 5. Right there. Okay, so the modulus operator. Okay, so you have plus, minus, divided, times, and then modulus operators, just like in C++. So the math works almost the exact same as in C++. Okay, so now also, when we get into string variables, strings, just like in C++, is not a primitive variable, but it is a class. Okay, and so being a class, that means there's a lot of methods, functions or methods that operate on it. And here's some of them right here, some of the useful ones in this chapter. Okay, so let's just, text is equal to you need to put in quotes, today is, well, no, it's Wednesday for me, maybe not you. Okay, and so now if I output text, it will print out, of course I didn't declare it as a string, an object of the string class. Most people just say variable. Unlike C++, you need to do a capital S for string. Okay, so today is Wednesday. Okay, but then we have all these string methods that operate on it. So for example, dot length. And their methods, you always have to have an open close. I'll just put an extra space in there just so you can, so that it stands out. And there we go. So the length in characters, you count the number of characters as 18. You include spaces. Okay, so you could look through some of those to see how they work. So like to uppercase method. And so that converts it to uppercase. Now you can add on additional methods. I can put another dot in another method. Okay, so here's to uppercase. But now let's go back to these string methods and let's just say substring from position 1 to n. So, okay, this one, I think this is kind of weird, to position first argument to before position. But okay, so it's kind of weird. But so over here, so dot substring. So then dot substring from position 0, the first character, to before 0, 1, 2, 3, 4, 5. Before 5. 5 is, index 5 is the space. Wait, 0, yeah. So before that's kind of weird. Okay, so that should give me the first word. Should output today. Okay, so once again, when you add, that's a neat thing that Java does, is that I can add additional methods onto this. You know, it's like, okay, this converts it to uppercase. Now I grab the first word. Now I want to see the length, dot length, like that. And so this will print out the length of the first word, which is 5. Okay, so kind of interesting on how that works, I think. And so back here, there's a lot more. You can look through all of these right here, the string methods. Here's a dot replace. That's kind of neat. This one is kind of, well, I'll go over that at a later time. So anyway, back here, you know, you need to download your file if you don't create an account to save it. And I think that's all I was going to call this introduction to Java video. Now you know the system.out.println command and variables and strings you can use. So have a great day.